Welcome to the engineering class for November the 16th. So I've looked at the homework that you guys turned in, or at least as of last night. If you turned in anything today, I haven't had a chance yet to look at it today. But as of last night, I looked at what people had turned in then, and it looked pretty good. Most people did very well. There were a couple people that had some minor errors, just little things. Like for instance, in one case, the circuit that you guys, or the circuit that one person sent me, if I had the voltage anywhere between 0 and 5, it worked the way it was supposed to. But once I got up to 5 or above, you know how the lights were supposed to flash in order to warn you that you're putting too much voltage in? Well, the lights didn't flash, so I couldn't give you full credit on that one. And so let me explain again. I said this last time, but it's worth saying again so you guys know what the deal is. Okay, so this is an Arduino. This is a real Arduino here. And I have had many Arduinos ruined over the years by people who plug voltages into the input sensors here that is too much. If you put in more than 5 volts, the Arduino can't handle that, and you will destroy the Arduino if you put too much voltage into this. So I think it's an important feature to make it so that if the input voltage is 5 or more, then I want the LEDs to flash. That's important. So if you were one of those people, I sent you a message telling you that you could redo it as long as you do it before the deadline. Otherwise, I can give you partial credit, but I can't give you all credit. And also one person on the other end, one person had it so that when I put the voltage all the way down to 0, then instead of getting no lights, I got 1 light. So everything else worked fine, but I wanted it so that if the voltage is 0, I didn't want any lights on. So again, I mean, that's a minor thing. You know, for the most part, you guys did really well. So congratulations on that. But there were quite a few of you who hadn't turned it in as of last night. And I haven't looked yet this morning to see. I'm hoping that the rest of you got it in this morning. I've just been too busy teaching to look at it. So before I move on to the new material, let me just pause and say, are there any questions about the old material? Any questions about last night's homework? Not seeing any, not hearing any. Okay, well, let's go ahead and start into tonight's homework. All right, so what we're going to do now is we're going to start into the final project for the electrical engineering module. So remember how this class works is, you know, we worked for a while on one engineering field, and then we have a final project for that, and then we move on to the next engineering field, work on that for a while, and then we have a final project, and then you move on to the next one. So the thing that we're going to start in today will be the final project for the electrical engineering module. Now, I don't expect that we're going to finish it all today. We're just going to start on it today. We still have a little bit. We're going to have a couple more times to finish it. But then once and so this project that we're starting into today, it will be the final exam for this project, and it will count as much as a midterm exam counts in a regular class. So it's very important that you do it and do a good job on it. And then after we finish with this, we will start into the next module, which I'm still debating which module we're going to do next. So let me think about that for a little while. There's a couple possibilities. All right, so we're going to do this the same way that we did with some earlier projects. I'm going to pretend to be the customer, and you are going to pretend to be the one person from your engineering team who is meeting with the customer in order to talk with the customer and understand what it is that the customer wants. Remember that the reason we do this is because we're assuming that you are part of a big team of engineers, but you don't want to have the entire team meet with the customer. Because I mean, if I'm sitting across the table and there's 30 people on the other side, you know, 30 engineers on that side of the table, and here I am the customer all by myself on my side of the table, that's pretty intimidating. And you don't want to intimidate your customers. Okay, so we're going to have one person represent the engineering team, and you are all going to pretend that you are that one person. So you are going to talk with the customer, understand what the customer wants, and then you are going to go back and you are going to write up a document that describes what the customer wants. Can somebody unmute yourselves and tell me what do we call that document that describes what the customer
Engineering
wants?
specification.
Wait.
No.
The functional specification.
Functional. Yeah, my bad.
Specification.
Yeah,
yes.
I knew that.
Okay, all right. Yeah, I figured you did. Okay, so yeah, the functional specification is what you're going to have to write up for your homework assignment tonight. Okay, now I don't expect that that's going to take too much time to do. So after you've written your functional specification, then you can start working on the engineering specification. Now, the engineering specification is not officially due next time we meet, but I would like you to get started working on it. Okay. But before we talk about the engineering specification, let's make sure we understand what the functional specification is. Okay, so what I'm going to do here is I'm going to take off my teacher hat and put on my customer hat. So I will pretend that I am the customer. You guys ready to start our meeting here? Okay, well, ready or not, here it comes. All right, thank you for coming to my company here and meeting with us today. I really appreciate you taking the time to come here and represent your engineering company. So what we do at this company is we sell electronic gadgets. We have a whole bunch of different gadgets that we sell, but there's one thing that we don't sell, and I've always wanted to add it to our store, is I want to sell a burglar alarm. I want to sell an electronic gadget that we could use in our homes so that we can set the burglar alarm, we can turn the burglar alarm on before we leave home to go to a restaurant or shopping or wherever. And if a burglar comes inside our homes while we're away, this burglar alarm will go off and make lots of noise and scare the burglar off. And then when I come home, I want it to give me some sort of an indication so that I know that a burglar has been there. Now, I need you to do it for the least amount of money possible. I can think of several different ways that we could do this, and I'm sure you could probably think of more. I mean, you're the engineer, right? I'm just a lowly customer. So you as an engineer, I'm sure you have even more ideas than I do. But there are a couple things that I'm going to want. So I want the burglar alarm to be one that works off of an Arduino. Now, I realize that you as an engineer, you could probably find some other way to do it, but I want it to work off an Arduino. So in a functional specification, you normally would not specify something like that. You would normally leave that open, but there is one exception. If the customer specifically tells you that they want it to be Arduino based, well, then that goes in the functional specification because that's what the customer said, and you got to give the customer what the customer wants. Okay, so I want it to be something that works off an Arduino. Okay, and the other thing is I want it to be working on some sort of a light sensor. And let me show you what I mean by that. Here, I'm going to share my screen here. Okay, so what you can see here is I've got the Arduino, and I've got something here that I'm going to talk about in a little bit later in more detail, but this is a light sensor. Okay, and this is the light that the light sensor senses. So if the burglar is not there, so let's pretend that the burglar is not there. Okay, so what I'm going to do if I'm the homeowner, okay, is before I leave to go to the restaurant or wherever it is that I'm going, I'm going to turn on a light. I'm sure you guys know that that's just a good practice in general. You don't want to leave your home all dark, And that's basically just inviting burglars to come. So you want to leave a couple lights on so the place looks like somebody's in there. And so this is the light that I'm going to leave on when I go away. And so if there's no burglar there, what happens is some of the light falls into the light sensor. And so the Arduino is going to see that light is hitting the sensor. And so the Arduino is going to know that everything is okay. But then, now let's assume that the burglar does come. All right, so the burglar is now here, and the burglar is standing here blocking the light. When the burglar walks in between the path of the light and the light sensor, they break the light beam. So the Arduino will notice that they're getting less light than they were before. And the Arduino is going to recognize that that means that there is a burglar present. And so when there's a burglar present, then I want the Arduino to set off this buzzer. And I don't want just one continuous beep. I want beep, 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 beep. It gets people's attention better. Okay, so this buzzer here is going to go beep, 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 beep. As long as the burglar is present, it's going to keep going beep, 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 beep. And by the way, I also want to turn on this light right here. This is an indicator light. Okay, and now the purpose for the indicator light will become clear in just a minute. So let's assume, so the burglar has come and they've tripped the alarm. So the alarm is going beep, beep, beep. And so the burglar gets scared. And so the burglar then runs away. Okay, so the burglar is not there anymore. So that means the light is getting back into the sensor. And so now the Arduino knows that the burglar has gone. So when that happens, then I want the beeper to stop. But I do not want the indicator light to go off. I want the indicator light to stay on. And the reason for that is because when the homeowner comes back from wherever it is that they went, they're going to look to see if this light is on. And so if the light is on, then they know that a burglar came by while they were gone, even though it's not beeping anymore because the burglar has now gone. But the fact that the burglar was there is important information. And so this light here will tell me that a burglar was there while I was gone. Okay. Now, are there any questions so far about what I've described?
Do you want the light to flash or just stay on?
Okay, thank you. That's an important question. I want the light to stay on. Okay, so when the burglar comes, the light comes on and it stays on solid, but the beeper it goes beep, 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 beep.
Is there a certain amount of time that you want it to beep for?
Well, I want it to beep for as long as the burglar is there. So
oh, well, yeah, never mind. That was a bad question because I forgot about the light stream. Second question. This is just for me. How would you turn it off without setting it off when you come home?
Well, I know where the light sensor is, so I would be very careful not to break the beam. See the burglar, they don't know that there's a light sensor there. And so the burglar, they just go walking around the house like normal. Okay, but I know where the light sensor is. So what I do is when I come home, I'll just be very careful not to break the beam, and then I'll turn off the light sensor. But that's an important question. Thank you for asking that. Can the rest of you think of anything that I may have accidentally, wink, forgotten to tell you?
What hertz do you want the buzzer to be, I guess?
Okay. I don't really care.
Okay.
You can choose that yourself. Anything else?
Like, what's the like timing that you want the buzzer to be on? Like, how long is it on and how long is it off?
I'm not too fussy about that. I don't want the beeps to be too long or too short. If the beeps are longer than 1 second, then that probably would not be desirable. If the beeps are anything less than about a half a second, that would probably not be desirable. So as long as they're somewhere between a half a second and 1 second long, and then the space in between the beeps would be about the same, somewhere between a half a second and 1 second. As long as you're in that range, that's good enough for me. I can think of a bunch more questions that I would ask if I was an engineer.
Do you want it to send like any type of notification to the homeowner, or do you just like want it to be alone, like in the house beeping?
Okay, that was really soft, and so a lot of people may not have heard it. So what she was asking was, do I want it to do more than just beep? Do I want it to like send a message to the police department or send a message to my phone? And the answer to that is, if this was a real honest to goodness burglar alarm, then most definitely yes, that is what I would want. But that's a little bit too complicated for ninth graders to do. So what I'm willing to do is I'm willing to say, let's just leave it with a beeper for now. But yes, you are right. In a real burglar alarm, I would want it to automatically call the police, but that's just too complicated for now. Anybody else?
This
Uh,
probably. Oh, go ahead.
Sorry. I guess one more thing is, do you want the indicator light to ever turn off?
Nope. Once the burglar comes, I want that light to come on and stay on.
Okay.
Until I find, when I eventually cut the power to the Arduino, then it will go off. But other than that, nope. Once that light comes on, it stays on.
I don't think. Does it matter what color LED we use?
Yeah, I don't really care about that. Whatever you choose. Okay, so let me tell you a few things that are in addition to what I've described that are very important to me as a customer that I accidentally, wink, forgot to tell you. And so make sure you include these in your functional specification as well. Let me go back to this picture right here. Okay, so when I activate the alarm as I'm getting ready to go to wherever I'm going, I would like to get just some kind of confirmation that the alarm is actually on and that the alarm is working properly. So here's what I want you to do. I want you to do what I'm going to call a startup sequence. So let me write that down. Startup sequence. Okay, so what that means is when I turn on the alarm, I wanted to go through a series of lights and flashes that it only does once and then it never does again, unless I were to turn the thing off and back on again. Okay, so here's what I want the startup sequence to be. The first thing is I want the lights to flash according to a certain pattern. And I want it to do a countdown pattern that's basically the same kind of countdown pattern that we have already done in a previous project. So hopefully you can just take the code from that other project and just copy and paste it into here. So the idea is this. When I first power up the Arduino, I want this light to flash 5 times, and then there's a little bit of a pause, and then 4 times, and then a pause, and then 3 times, pause, 2 times, pause, 1 time, pause. So that's just kind of a countdown, 5, 4, 3, 2, 1. So that when I see that counting down, it just gives me a good warm, fuzzy feeling. So I know that the thing is working right. Now, I also would like some confirmation just to know that the buzzer is okay. And so after it has counted down from 5 to 4 to 3 to 2 to 1, then I want it to give a short beep. Just a half a second or 1 second, just one little beep, just so that way I know that the beeper's hooked up, it's working, I know that the lights hooked up is working. I know the program is working. Okay, so this is the startup sequence that I want the Arduino to do when I first powered on. And then after that point, then it just goes into silent mode. And it goes into what I'm going to call lookout mode. Okay, so let me give that a name. So lookout mode. Okay, so after the startup sequence is done, then I want this light to be off. I want the beeper to be silent. I want the Arduino to sit there in stealth mode, quietly, just watching. And so hopefully then when the burglar comes, the burglar won't pay any attention to the Arduino, and the burglar will just go walking around, and they will break the beam here and cause the light sensor to not have as much light as normal. And so then the Arduino will recognize that the burglar is there. Okay, so in lookout mode, I want the light off, I want the beeper silent, and I just want you to watch to see if a burglar is there. And if the burglar is there, then I want you to stop being silent. That's when I want this thing to go beep, beep, beep. And that's when I want this light to come on, like we already described before. Okay, so the thing that's new here that I didn't talk about last time was this thing that I call the startup mode, the startup sequence, if you will. Okay, so I want you guys to do that. Okay, now, one thing that I expected that you would ask lots of questions about that nobody has asked anything about yet is the sensor. We haven't talked about how the sensor works. And I was really hoping that you would ask a lot of questions about that. Okay, so let's think about this. Have any of you guys worked with light sensors of any kind in electronics? Do you know there are different types of light sensors? No? Okay, apparently not. Okay, so this is a light sensor that would be the easiest one for us to use. This is a solar panel, and you can see it's got two wires here. And so if there is light falling on the solar panel, then it generates a voltage. And so what I could do then is I could just take this and I could just hook it directly up to my Arduino. I would take the black one and I would connect that to the thing that's called ground. Okay. And I would take the red one and I would connect that up to the same place where you guys connected up the power supply in the homework that was due today, right? So basically you could take the circuit that you turned in as your homework today and replace the power supply with this solar panel. And so then if the burglar is not present, then we have light falling on the solar panel. And so the Arduino will see some voltage on the input pin. If the burglar then walks by and blocks the light, then the Arduino will see that the voltage on the input pin has dropped. And so the Arduino is going to say, aha, there must be a burglar present. And so then the Arduino will go into burglar alarm, alarm mode. It'll start beeping and everything. Okay. So if we were to use this solar panel, that would be the simplest thing for you as an engineering team to do. But I, as a customer, would not be happy with that because solar panels are pretty expensive. And, I have to compete against other companies. So if I'm selling a solar panel that has expensive components in it, it's going to cost me a lot to make the burglar alarm. And so, I'm going to have to sell the burglar alarm for a lot of money in order to be able to make a profit. If my competitors can figure out a way to make a burglar alarm that doesn't use expensive solar panels, but instead uses a very cheap thing called a photoresistor, which is really, really cheap. Okay. If my competitors are selling burglar alarms that are made out of components that are a whole lot cheaper, then they can sell their burglar alarm for less money, which means that nobody's going to want to buy my burglar alarms, because my burglar alarms are going to cost a lot more. So this solar panel, so I want you to put this as part of your functional specification. I say you are not allowed to use a solar panel because that would be too expensive. What I want you to do instead is I want you to use a special kind of resistor called a photoresistor. Now, we have not yet worked with photoresistors, and so you're going to need to learn a little bit about photoresistors. Let's go ahead and open up the Tinkercad, and let's see how photoresistors work. All right, so here is a burglar alarm that I made that pretty much, well, that does do the job that I want it done. So before we talk about photosensors, let's just look at the burglar alarm, and I want you to verify that it does in fact work. So I'm gonna hit start here in just a minute. So before I do that, let's see. How about Anish? Can you unmute yourself and just remind us what is supposed to happen when I first start up my my burglar alarm? Remind us, what is the sequence supposed to be?
If I remember correctly, the light is supposed to flash 5 times, then 4 times, 3 times, 2 times, 1 time, and then after just a short beep.
Okay, good. And then it's supposed to go into lookout mode.
Yeah.
All right, good. Okay, so let me start it up and let's see if that is in fact what happens. Okay, so here goes. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3. 1, 2, 1. There's the beep. Okay, good. We got a problem here. What's happening is that the thing is continuously beeping. Okay, so this is because of a weird thing about Tinkercad. So if you look down here, this is the photoresistor that we are going to be using. Now, a photoresistor is a variable resistor. So imagine you take a regular old boring normal resistor like that one, okay? But you could somehow change the resistance depending on how much light hits on it, okay? So when this resistor is in the light, it has a very low resistance. And when it goes dark, as I slightly hear that came on. Okay, so this little slider here allows me to simulate in software what would happen. So over here, we're assuming that the resistor is in light and therefore the resistance is very low. As I slide this thing over to the right, then what we're doing is we're pretending that it's getting darker. And the way photoresistors work is when they get darker, the resistance goes up. And so as I slide this over, okay, so that means that the burglar is there. And now the burglar has gone away. Okay. Now with Tinkercad, when you start your simulation, it always starts the simulation assuming that the photoresistor is in dark. Okay, so what I need to do then is if I want the thing to not beep, I have to cheat a little bit here. Okay, so what I'm going to do is I'm going to stop my simulation, and when I start it, I'm going to come down really quickly, and I'm going to turn the photoresistor to the light rather than to the dark. So here goes. I start that, I click here, and I really quickly bring it over to the light. Okay, so now you look up here, you see we're still in the startup sequence. That was 3, 1, 2. 1. Okay, good. Okay, so we went through the startup sequence fine. We got 5, then 4, then 3, then 2, then 1, and then I got 1 beep. Okay, so now I know that the burglar alarm is working. so I can go off and go off to a movie or wherever it is that I'm going. And the burglar alarm is now in what I call lookout mode. So the burglar alarm is now watching this photoresistor. And right now, the slider is over there set to the light. So that means that we're assuming that the burglar is not there blocking the light path, right? And then when the burglar does come, then he's going to cast a shadow on the resistor, and the burglar and the alarm is going to see that. Okay, there we go. So now the burglar gets scared and the burglar runs away. So when the burglar goes away, then the light comes back and it's falling on the sensor again. So now we know the burglar is gone. But notice you see the light is still on. So that I, as the homeowner, when I come home from wherever it is that I was, I look at the light and I see, the light is on, so I know a burglar has been here. Okay. And if the burglar ever comes back, okay, I want that light to go back on again. Okay. So that's part of the functional specification that I think I forgot, wink, wink, to tell you is, and I want to make sure you guys include this in your functional specification, is that if the burglar comes back at any time before the homeowner comes home, I want that beeper to start beeping again. Okay. All right. Now, we still haven't yet talked about the photo sensor and how it works, but I just want to make sure, does everybody understand, other than the photo sensor, does everybody understand what I want to see in the functional specification? So please type yes if you fully understand everything, except for the photo sensor. I realize you probably don't understand that. Okay. All right. So I did see one person said no. So, Adam, can you think of a question that you can ask to answer? And I see a couple kindas. So those of you that said kinda, can you think of a question that you could ask to help you understand better what it is that I'm looking for? Nope. Okay. All right. Okay. And then Adam is saying that he just mistyped. Okay. All right. So remember, your homework tonight is to write up the functional specification, but you are going to have to understand a little bit about this sensor and how this sensor works. So let's zoom in a bit here on the sensor, and let's see if we can understand that a little bit better. So remember that this thing that you're seeing right here is really just a variable resistor. Okay, so let's see if we can draw a schematic diagram that mimics what you're seeing. So let's start with this right here. So that's 5 volts. So that's the same thing as if I had a 5-volt battery, and that's plugged into the positive side of the 5-volt battery. So that's like saying it's the plus side of the battery. So then the electricity comes out there, and then it goes through a resistor, and this is a fixed resistor. Okay. And then the electricity comes through here, and it comes to a point right here. And here you can see the electricity can go 2 ways. One way is go through that resistor and into the ground, and the other way it goes into the Arduino, right? So this point right here, okay, right here, this point right here is a junction. So I'm going to have 2 wires coming out here. One is the wire right here that goes to the Arduino. And the other wire comes out here that goes through my variable resistor. So the way that variable resistors are drawn is first you draw the symbol for a normal resistor, and then you put an arrow through it like that. Okay, So that arrow tells you that it's a variable resistor. That's just the way that they do. All right. Okay. So let's do some sample calculations to find out what is the voltage going to be to the Arduino for different values of these resistors. Okay, so let's assume that our variable resistor gives us 250 ohms if it sees light. And let's assume that it gives us 750 ohms. So let me make that 7 look a little bit better there. Let's assume that it gives us 750 ohms if it's in darkness. Okay. All right. Let's assume that our fixed resistor is, oh, I don't know, let's say 375 ohms. And it's fixed, so that means it's always 375 ohms. Doesn't matter whether it's light or dark, it's just always 375 ohms. Okay, so what I want you guys to do right now is I want you to calculate what is the voltage to the Arduino if the resistor is in light. Okay, so what we're assuming is that the burglar is not present. And so this resistor here is 250 ohms. And this resistor is 375 ohms. So I want to know what is the voltage to the Arduino in this case. Right? Now, let me open up a whiteboard here and see if we can do this a little more simply. So let's assume that I have a circuit that looks like this. Okay, this is 375 ohms. And this one here I said was 250 ohms. And I want to know what is the voltage across this resistor. So this here is the line that goes directly to ground. So this is called ground. And this here is plus 5 volts. Okay. Think back to what we did a week or two ago when we were talking about resistors, and we talked about resistors that are hooked up in series. Okay. Let's see. So here's what I want you guys to do right now. Let's do this problem in 2 steps. So step 1 equals, I want you to find the current that is flowing through this circuit. Could you guys do that? Let's see. So here's what I want you guys to do. I want you to do the math, see if you can calculate what is the total current that is flowing through this circuit. So the battery is going to put current out here and it's going to come in like that. So I want you to find out what is the current, and then step 2 will be to find out the voltage across here. But let's just take it one at a time. Now, what I want you to do is I want everybody to try this on your own. And when you get an answer, I want you to type it in the chat box, but do not put it in a public message. I want you to put it in a private message to me. So I'm going to sit here quietly and wait while you guys calculate how much current will be flowing through this circuit. If you have no idea how to do this problem, then tell me in a private message saying, I don't know. If I don't see a lot of I don't knows, then I'm going to assume that you do know, and I will sit and wait. Okay, so I'm seeing 1 I don't know. Okay, I'm seeing 2. Now I'm starting to see some answers. Okay, good. All right, so Adam just sent me an answer. I'm seeing a lot of I don't knows. Okay. Oh, good. Justin just sent me an answer. And Justin's answer is the same as Adam's is. That's encouraging. Callie just sent me an answer. And her answer is the same as Adam's and Justin's. That's good. KJ, yeah, your answer is not the same. Okay, so I'm seeing a bunch of I don't knows. Let's see. Adam, you were the first one to send me an answer here. Would you mind unmuting yourself and telling me how did you get your answer?
Okay. So I looked back at, or I remembered the equation, which was current equals voltage over resistance,
Okay, and what is the name of that equation?
Ohm's law.
Okay, very good. So he remembered Ohm's law. Very good. Okay, and then what did you do with that?
I remembered that resistors in a parallel thing, you just add the resistance to get,
I'm sure that what you meant to say was resistors in series, you add the resistance.
yeah, series.
Okay, because if it's parallel, then it's a different thing. Okay, so
Yeah, my
Adam
bad.
is saying that the total resistance here is just the sum of these two. So whatever 375 plus 250 is. So I'm thinking, is that 625?
Yeah, that's what I got.
Okay, so Adam is thinking that the total resistance is 625 ohms. Okay, so I'm guessing that you put that number in there. And the voltage is 5, so you put 5 into there.
Mhm.
Okay, so I then equals 5 divided by 625. And I make that 5 a little better there. Okay, and then what number did you get, Adam?
0.008, which is 8 milliamps.
Okay, very good. Okay, so I'm sure, I hope that you guys all remember that whenever you're working with Ohm's law, you can't work with milliamps or kilovolts or micro ohms or anything like that. It has to be regular volts, regular ohms, regular volts. Okay, so the number that comes out here is going to be in amps, so 0.008 amps. Now, Adam remembers that most electrical engineers, they like to adjust the units so that they would call it 8 milliamps. But whenever you're putting it into the calculations, you want to put it in as 0.008. Okay, and what I see is that a lot of you, that is in fact the number that you got. A few of you got a different number. I'm not quite sure where you got your other number from, but this is in fact the right number. That is the current. Okay, so that's step 1. Now, step 2, what we want to do is we want to calculate what is the voltage that the Arduino is going to see. So remember the way it works with the Arduino. In fact, let me come back here to this picture right here. Okay, so remember the way that the Arduino works is it looks at this pin right here, which is the A0 pin, and it will report a number that depends on how many volts it sees on that A0 pin. All right, so the way we've got it hooked up here is that whatever is the voltage across this photoresistor, whatever is delta V for this resistor right here, that will be the voltage that the Arduino reports. These two, they will be the same. So if we go back now to our whiteboard, if we can figure out what is the voltage difference from this side of the photoresistor, because this is our variable resistor. So if we were to take a multimeter here and we hook up one side to this, or one lead to this side and the other lead we hook it up to that side, whatever the multimeter is reading as the voltage difference, that is what the Arduino is going to see as the input voltage. Okay, so what we need to do then is we need to calculate what is delta V just for the 250 ohm resistor. Can anybody think of how we could do that? So I want to know what is delta V just across this resistor only, not the total. I don't want the total voltage. I just want to know what is the voltage across this one resistor.
Would you just divide 5 and 250?
Ah, okay. So it sounds to me like what he's saying, let's take Ohm's law, which I equals V over R. Let's rearrange it so that we can get some expression that will tell us what V is. Okay, so if we multiply both sides by R, then the R is going to go away. And so what we're going to get left with is R times I equals V. Okay, now if the R that we put in here is this R, then the V that we get out will be this V. It won't be the total V. It'll just be the V, the voltage across this one resistor. Okay. So we didn't know what I was when we first started into the problem, but now, thanks to Adam, we do know. The current that's flowing through this resistor right here will be 0.008 amps. And we know what the value of this resistor is. The value of this resistor is 250. Okay, so what I think I heard you just say is let's use Ohm's law rearranged to figure out what is the voltage. Okay, so if I take R, which is 250, times the current flowing through it, which is 0.008, okay, I get the voltage is 2.0 volts. So you see how this works? If the burglar is not there, then here, let me get rid of some of these lines here. Let me clean up my drawing just a little bit here. Okay. So if the burglar is not present, then my photoresistor, we're assuming has a resistance of 250 ohms, and the voltage across it will be 2 volts if there is no burglar. Okay. So far, so good. Can everybody type in either yes or no into the chat box? Say yes if you followed what we did, and say no if you didn't follow what we just did. Okay, I'm seeing a lot of yeses. Okay, very good. Okay, so now, what if the burglar is present? Okay, so remember the way photoresistors work is that the resistance changes if they're in darkness. Okay, so if a burglar is present, this number is not going to be 250 anymore. This number is going to be something different. So for the sake of what we're doing right now, let's assume that it changes to 750 ohms if the burglar is present. Okay. So what we need to do is we need to recalculate it for this new value. So we're just going to repeat what we did. We're just going to have different numbers. So let me open up a new white page here. And so we're going to have the same voltage as before. And the fixed, so the voltage was 5 volts before, and it's still going to be 5 volts. Our fixed resistor was, how much was it before? I forgot already. It's 375. Okay. So our fixed resistor was 375 ohms. Well, that's going to be the same because the fixed resistor doesn't change. But our variable resistor now is going to be different. Instead of 250, it is now 750 ohms. Okay, so if this is the line that goes to the Arduino, let me spell that correctly, to the Arduino, then I want to know what that new voltage is going to be. So here, I'm going to ask you guys to do it again. All you need to do is repeat exactly what we did before. So step 1 is find the new current. Okay, so because this resistor is now a different value than it was before, the current is now going to be a new current. Okay, so step one, find out what is that new current going to be. And then step two is find the new voltage for that. Okay, so I'm going to sit here quietly. Oh, good. I see that some people are already way ahead of me. Excellent. Okay. So well, I just saw two numbers, but the numbers that I saw are not the same. So Adam and Ibrahim, one of you has made a mistake somewhere. Okay, so Callie just came out. Now, Callie, that number, that's the current you're saying. Okay, good. All right, now go ahead and take the next step. I want you to find the voltage too. Okay, keep going. I want to see more answers here. So KJ, I want to see both. I want to see the current first, and then I want to see the voltage. Okay, it looks like people are agreeing. All right, so the answer that I'm seeing from almost everybody now is that the current is 0.004 amps. And some of you are calling that 4 milliamps, which is a very good way to do it. Okay, and so let me see if I agree that that is the right thing. So let's see, my total resistance is 375 plus 750. That's my total resistance. So if I do 5 divided by my last answer. So yeah, so actually I'm getting 4.4, but I mean, you guys just rounded it off. That's okay. So I'm getting 0.00444 repeating. Okay. So if I were to put that in terms of milliamps, I'm getting 4.44 milliamps. Okay, good. Now step two. I want to know what is the voltage going to be across this resistor. So I want to know if I were to measure from here to here, and I want to know what is delta V just across that resistor. All right, I'm seeing a couple numbers here. I want to see some more answers. Okay, good. So far, the answers that I'm seeing are all the same, so that's reassuring. But some of you aren't typing numbers into the chat box here. I need everybody to do this. Anish, I'd recommend you go back and do that one again. Now, it could be that you're right and everybody else is wrong, but the odds are not very high on that. Okay. Kelly, that's, yeah. Oh, Sophia, go back and redo that one again. Joseph, I'd recommend you redo that one. Okay, tell you what, let's do this together. So who was the first one to send me? Okay, so Justin, you were the first one to send me the voltage. So would you mind unmuting yourself and tell me, now that we know the current, how did we get the voltage?
Right. So like we talked about last time, if we want to find voltage, the version of Ohm's law would be V equals current times resistance.
Okay,
So
V equals current times resistance, or resistance times current. Okay, good.
So we know that the resistance is 750 ohms for that part of it, and
Okay.
the current is about 0.004.
Okay.
So if you multiply those together, you get about 3 volts.
Yeah. So when I do it, carrying the extra significant figures, so I get 3.33 repeating, which you've gone ahead and rounded off to, you just called it about 3 volts, and I'm okay with that. All right. So this is the voltage they will see if the burglar is present. Okay, so remember that if the burglar is there, the Arduino is going to see 3.3 volts. If the burglar is not there, then the Arduino is going to see 2.0 volts. Okay, so all you guys have to do is write your Arduino code so that you put in some sort of a threshold. Okay, so let me go new. Okay, so if no burglar, then the voltage equals 2.0. If yes burglar, then the voltage equals 3.3. So what you need to do is you need to pick what's called a threshold voltage. That's somewhere in between there. Okay, so you could put it at 2.5 if you wanted. You could put it at 2.6, 2.7. You get to pick whatever threshold it is. But as long as it's somewhere in between these two extremes, okay, then you can write your Arduino code so that as long as the voltage is less than whatever threshold you pick, then the Arduino stays silent. If the voltage ever jumps up to be higher than whatever threshold you've picked, then the Arduino turns on the light and starts beeping. Okay. Is everybody clear with how that works? So type in yes if you think that you understand that. Type in no if you are still a little bit iffy on it. Okay, so I'm seeing lots of yeses.
I have a quick question.
Yes.
Why does that other resistor have to be there?
Because if the other resistor isn't there, then the voltage would always be 5 volts. So let me, I'm glad you asked that. Thank you very much for asking that. So let's start up a new whiteboard. Okay, so let's suppose I have a 5-volt battery here and I connect this up to my photoresistor. So this is the photoresistor and I don't have the other resistor. Okay, so what's going to happen is if I take my multimeter and I hook up my multimeter here, so one of the leads goes here and the other lead goes there, it is always going to read 5 volts. No matter, it doesn't matter what the value of this photoresistor is going to be. The voltage is always going to be 5 volts. Now, if the value of the photoresistor changes, what will happen is that the current will change. But Arduinos don't read current. Arduinos only read voltage. And the voltage is always going to be 5 volts if you only have one resistor. You have to have 2 resistors. That's the only way you're going to get the voltage to change.
Okay, I understand.
So thank you for asking that. Okay, so KJ just asked, he says, do we want to put the voltage into the functional specification? So the answer to that, KJ, is no, because you don't need to use the values that I used for the resistors. You may choose to use different resistor values in your final product. And if you choose different resistor values, then the threshold voltage is going to be different. And in fact, I'm glad you asked that because I'm going to open up Canvas right now so that you can see the homework assignment. And what you're going to see is that there are actually 2 things that I want you to do in tonight's homework. Okay, so let's go into here. So here is Canvas. Let's click on the modules. And let's go down here. So functional specification, burglar alarm, and also calculate Arduino input voltages. Okay, so. All right, so in Canvas, you'll see I have a picture of my little creation here. And if you come down and you read the description, you'll see that there are 2 things that I want you to do. First thing, and by the way, this is the most important thing. Okay, is I want you to do the functional specification. All right, that is the most important thing. If you did that and nothing else, then you will have done the most important part of the assignment here. Okay, I want you to write up a functional specification for the burglar alarm. And so everything that I just talked about in class, I want you to include that. And by the way, this is all being recorded. So if you don't remember everything, then come back and watch the recording so that you capture all of the important stuff. That's the functional specification. Then, if you also have some time left over, then I would like you to go ahead and do the next part, which is this part down here. I want you to redo the calculations that we just did, but this time I want you to use different assumptions on what the resistor values are. Okay, so I want you to assume that the fixed resistor has a value of 10 kiloohms. Okay, so if I were to draw the circuit here, remember we have a fixed resistor and we have a variable resistor. All right, so I want you to just basically redo the calculations that we got through doing just a minute ago, only with different numbers. So what I want is I want the fixed resistor to be 10 kiloohms, which is 10,000 ohms. Okay, and then this variable resistor, I want that to be, here, let me go here. Okay, I want that to be 500 ohms if the light is shining on it. So 500 ohms if there is no burglar. Okay, and so I want you to calculate what is the voltage to the Arduino going to be. So this is the thing. Let me change that to black here. Okay, so this is the line that goes to the Arduino. Okay, I want you to calculate what is the voltage to the Arduino if this resistor is 10,000 ohms and this resistor is 500 ohms. Okay, that's if there's no burglar present. Now, if the burglar is present, then the numbers are going to change. Not the fixed resistor, but the other one will. And notice it changes by a lot. Okay, so this time, instead of being 500 ohms, I want it to be 180 kiloohms. So that means 180,000 ohms, which you might think that that's a ridiculously high number, but in fact, that's what photoresistors, that's actually a typical value for a photoresistor. You get a huge range in resistance if the light is shining on it compared to what you don't. Okay, so the first time I want you to do this, assuming that the burglar is not present and this resistor here is 500 ohms. The second time you do it, I want you to assume that the burglar is present. So this resistance there changes to 180,000 ohms. And then you're going to recalculate what the voltage is. Okay. So this second part here is going to be a little bit trickier, but I'm confident that most of you can do it. If you are one of the ones that has trouble with this, well, don't lose too much sleep over it. Remember that this part up here, this is the most important part for tonight. Okay, most important part for tonight is this one right here. If you didn't do this one tonight, I would not be upset. Now next time we meet, then that second part is going to be really important. But for tonight, the most important part is just get the functional spec written. Okay. Are there any questions?
Yeah, Mr. Hendricks. So you said that we could change the resistors values to whatever we want. Is that only? Carry on. Yeah.
Well, go ahead and finish your question.
Yeah, that was basically my question. Like,
Okay.
when can we change it?
Okay, so next week is when the final project is going to be due, and you're going to make it in Tinkercad. So when you make the final project, you can pick any values you want for the resistors. Okay, but that's in the final project that's due next week. For tonight's homework, I want you to use my numbers. But in the final project, you can change them to whatever you want.
Okay, thank you very much.
You're welcome. Anybody else have questions? Not seeing any, not hearing any. Okay. All right. Well, if you don't have any more questions, you can type "bye" into the chat box, get working on the assignment. If you do have a question, but you didn't want to ask because it was being recorded, here, I'll turn off the recording, and then you can ask your question without it being embarrassing.